The existence of multiple crossovers means that the amount of recombination between the outside markers A and B, AB, is usually less than the sum of the recombination frequencies between A and C, AC, and C and B, CB. To obtain a more accurate approximation of the distance between the outside markers, we calculate the probability, AC x CB, that when a crossover occurs between C and B, a crossover also occurs between A and C, and vice versa, CBX AC. This probability subtracted from the sum of the frequencies expresses more accurately the amount of recombination. The simple formula AB equals AC plus CB, 2ACCB, is applicable in all cases where the occurrence of one crossover does not affect the probability of another crossover. Unfortunately, accurate mapping is often disturbed by interference phenomena, which can either increase or decrease the probability of correlated crossovers. Using such reasoning, the Columbia University group headed by Morgan had by 1915 assigned locations to more than 85 mutant genes in Drosophila, Table 1.1, placing each of them at distinct spots on one of the 4 linkage groups, or chromosomes. Most importantly, all the genes on a given chromosome were located on a line. The gene arrangement was strictly linear and never branched. The genetic map of one of the chromosomes of Drosophila is shown in Figure 1.8. Distances between genes on such a map are measured in map units, which are related to the frequency of recombination between the genes. Thus, if the frequency of recombination between 2 genes is found to be 5%, the genes are said to be separated by 5 map units. Because of the high probability of double crossovers between widely spaced genes, such assignments of map units can be considered accurate only if recombination between closely spaced genes is followed. Even when 2 genes are at the far ends of a very long chromosome, they are sorted together at least 50% of the time because of multiple crossovers. The 2 genes will be separated if an odd number of crossovers occurs between them, but they will end up together if an even number occurs between them. Thus, in the beginning of the genetic analysis of Drosophila, it was often impossible to determine whether 2 genes were on different chromosomes or at the opposite ends of one long chromosome. Only after large numbers of genes had been mapped was it possible to demonstrate convincingly that the number of linkage groups equaled the number of cytologically visible chromosomes. In 1915, Morgan, with his students Alfred H. Sturtevant, Herman J. Muller, and Calvin B. Bridges, published their definitive book, The Mechanism of Mendelian Heredity, which first announced the general validity of the chromosomal basis of heredity. We now rank this concept, along with the theories of evolution and the cell, as a major achievement in our quest to understand the nature of the living world.